Now, we can occasionally avoid trigonometric substitution by just remembering a few simple inverse trig antiderivatives. So what do I mean? Well, it's a fact, and you can prove this using trigonometric substitution, that the integral of 1 over 1 plus x squared is the inverse of tangent x plus c. The integral of 1 over the square root of 1 minus x squared is the inverse sine and then finally 1 over x square root x squared plus 1, minus 1 dx. That would be the inverse of secant of x plus c. And as usual with these secant substitutions, the caveat is that the domain of x is assumed to be has to be strictly greater than 1, otherwise we would get a 0 in the denominator. So how can we use these to avoid trigonometric substitution? Well, let's just see it by example. I want to find the integral of 3 over the square root of 9 minus x squared dx without trig substitution. All right, so if the problem says I can't use a trig substitution, then I'll have to play by the rules and not use a trig substitution. But I will need to know a trig antiderivative, and specifically looking at this problem, I see that it looks an awful lot like this problem up here. You can kind of see the similarities. You've got a fraction over a square root, constant minus a squared variable term. That's going to be what we're going to want to make the problem look like. We want to make it look like what I have circled here in green up here. So how am I going to do that? Well, I'm going to have to do some factoring first, because this 1 that you see right here is important. I will definitely have to get a 1 taken care of first. So that should not be too hard. I'll come back down here and I'll factor out from the denominator a square root of 9, and that would leave me with 1 minus 1/9 x squared with 3 on the top. Okay, well then heck, 3 and the square root of 9 cancel each other out, don't they? So I'm really close to it. You can put a 1 up here on top if you like. So I've got 1 over 1 minus 1/9 x squared. What I would really like is to replace that with just a single variable, u squared. So that's what I'll do. I'll let u squared equal 1/9 x squared. Although what I'm really doing is letting u equal 1/3 x, the square root of both sides. And that would mean then that 3u would equal x, and 3du would equal dx. All right, so that's all well and good. Let's make those substitutions up here. So I've got the integral. So dx gets replaced with a 3 du, and I'll go ahead and factor out that 3 to the outside to get it out of my way. I've still got a 1 on the top, square root 1 minus, and 1/9 x squared gets replaced with the u squared. And heck, that is exactly, I've gotten to where I want to get. Where I have 1 over 1 minus, it's a u instead of an x, but that's fine. That's going to be the inverse sine of u, just applying with my formula directly. So let's take care of that. That's 3 inverse sine of u plus c, just by the formula. And then I can replace my u with a 1/3 x plus c. And so I did not do any trig substituting. Notice that my variables did not involve any trig in the substitution process. I just used my existing formulas. Now there's nothing stopping you from using a trig sub if you wanted to, other than the fact that this problem required you not to use the trig sub. And it kind of depends from person to person or from problem to problem what the best method is. And so it's good to be able to know how to do both.